Sorry, National 5. Just playing a little bit of guitar. Nova's about to go into the land of Nod, and it is the start of 2021 with Lockdown 2.0 online learning. But guys, I brought my guitar for two reasons. One, to talk about waves. Two, to make you laugh. It is Monday morning. You didn't think Mr. Bill had a guitar and was going to sing to you on Monday morning. So, sit back and enjoy these next 90 seconds. They're going to be good. I'm so done with lockdown. I really am. I'm so done with lockdown. Hurry up, vaccines getting pretty taxing. You really do need to hurry up with it. Hurry up, vaccines getting pretty taxing. Now, you're bored, it's lockdown, I get it. You go on YouTube, like most of us do, and you click on Mr. Bill's Physics, you subscribe even. You get notifications. Why? I'll tell you why. Because of this. Mr. Bill's Physics is awesome. It is. Mr. Bill's Physics is awesome. Why? Because I guarantee an E if you watch me every day. I really do. I guarantee an E if you watch me every day. Beautiful. Beautiful. So I hope you enjoyed that little sing-song. Why did I bring my guitar number 2? Was because I'm going to be talking a little bit about waves. Now, guitars are perfect to talk about waves. You've got amplitude, you've got wavelength, you've got frequency, you've got crest, you've got troughs, you've got energy, you've got speed of sound. So, you know what I mean. We could talk days about waves with a guitar, but we don't have days. We've got about 15 minutes. So what I'm going to do is I'm going to jump over to a screen share of a PowerPoint, because you guys need to know a lot more than me just saying some of those words. You need to know equations. You need to know how to answer past paper questions, which I have got ready for you guys. Past paper questions of waves and material that you will need in order to pass this prelim. It's stuff that you've not done for a while, so that's why I'm sharing with you. So I'm going to go over to that screen share in 3, 2, 1, and go. Welcome National 5, what a fun little start we've had there. Just want to welcome you to Mr. Bill's Physics Lockdown Sessions 2.0. And we're going to be looking at prelim revision today. So before we get on with anything, I want to talk to you a little bit about what to expect from National 5 Physics during this Lockdown 2.0. So there will be 3 lessons per week, 2 revision lessons and 1 new lesson. And that new lesson is going to be in properties of matter. It's not a huge topic. Like, we could probably finish it in 2 weeks, but we'll probably do it in about 3 to 4 weeks. And we'll probably have to finish it when we come back in February. So how's that going to look like throughout the week? Well, lesson 1 is going to be the kind of start the revision, like what I'm doing today, going through some of the revision materials and then setting some past paper questions for you guys to work on throughout the week. Lesson 2 will be on properties of matter, and lesson 3 will be going over the past paper questions that I sent out on lesson 1. Expectation of you is to complete the revision assignment, which is the past paper questions and the class work from the new topic. It should not take you any more than an hour of your normal day or your normal week that you would have in physics anyway. So it should be fairly standard stuff to get through. All material will be posted on your individual classrooms, so you'll be kind of chatting, corresponding with each of your teachers for more info and questions and such. Now, subscribe, like and share. If some of you are visiting the channel for the first time and you're a big YouTuber, subscribe to the channel. Alright, I don't do this for free. No, I do. I really do. I don't have enough subscribers and people look at my stuff to get any money yet, but that could change. That could change, and you're helping me change my future. Right, let's move on to Unit 1, Waves, and talk about the first part of the course, which is wave characteristics, diffraction, sound, and EM spectrum. We're not going to spend too long on each of these. It is revision, and you have your notes there ready for you to kind of look at anyway. Now, prefixes. What are some of the prefixes that we have looked at? Well, looking at this here, we have a whole bunch of prefixes that you should be used to. Giga, mega, kilo, milli, micro, maybe nano if you have come across a couple of questions, but we should be aware of that. Please understand it, know it, look through it, and yeah, really get yourself familiar with that. That is an important tool for your prelim. Now let's talk about wave characteristics. Now the amplitude. Remember, the amplitude is the distance between the middle line, like the dotted line there, and the top of the crest, or I guess the bottom of the trough if you were looking at it that way as well. But it's just the height of the wave. Now the amplitude is corresponding to how much energy the wave has. So if you have a big wave, then you're going to have a big amplitude. All right. Now waves carry energy. They transfer energy. That's one of the main things that waves do. They transfer energy. Now looking at this, we have peaks and troughs. The peaks are just at the top, so see the pointy bits at the top, that's peaks, and the bottom are troughs. Okay, so that's something that, again, you wouldn't probably be asked that in an Astro 5 exam. You just kind of know that. This is a good diagram of a wavelength. A wavelength is between two crests or between two troughs, as labelled there. It's measured in meters. It's also when a wave starts to repeat itself. So sometimes you might have to count how many waves or the wavelength, and sometimes it is basically between 2 points. It can be between the crest and crest, trough and trough, or between the wave starts to repeat itself. Okay. Wavelength sometimes comes across as lambda, and that's a capital lambda, so it's just, you're probably aware of lambda by now, but it's a slightly odd Greek letter, if you remember. Now frequency. Frequency of a wave is the number of waves produced divided by the time taken seconds. Sorry, that time taken seconds should be underneath that line in number of waves produced there. And we're going to come to an equation sheet anyway, just in a couple of slides time, that kind of summarises it. But remember, frequency is measured in hertz, capital H, small z. And we talk about pitch. Higher pitch means a higher frequency. Okay, and frequency almost means like the waves coming closer together. Then we also have an equation where we said V equals F lambda. V equals F lambda is an equation we can use to find out speed, frequency, or the wavelength of a wave, measured in meters per second for speed, hertz for frequency, and meters for wavelength. As I said, waves transfer energy. We sometimes also have something called a period. That's just the time it takes for one wave to pass a point. We're going to come to an equation on that in a second. We've got some of those things summarised in that diagram there. We also have two things, transverse and longitudinal waves. Remember, longitudinal waves are only for sound waves. Transverse waves for all EM spectrums, water waves, and anything that's not sound waves, essentially. Transverse waves are defined, and you often get these in exams and prelims, and multiple choices. You need to know the definitions for these. It's the direction of vibration at right angles to the direction of travel, I should say. And longitudinal is the direction of vibration and is parallel to the direction of travel. All right, so please know them because they might come up. Now these are the equations. All right, D equals VT. That should be fairly standard for most of us. We have speed equals frequency times wavelength. We just talked about it 2 seconds ago. We have T equals 1 over F, which is period. Remember, that's the time it takes for one wave to pass a point. And we have frequency equals N over T. That's the number of waves divided by the time. Those are 4 equations that you will need to know, and they're always going to come up in waves questions, okay? And now looking back, you should be fairly good at answering questions like this because you've now got the skills to do so much more than you did when you were in S3. Right, so diffraction, very quickly, diffraction, remember, for longer wavelengths, diffract more than shorter wavelengths. Okay, so longer wavelengths diffract more than shorter wavelengths. So looking at these diagrams, radio waves will diffract more than TV waves. And by diffracting, they mean the bending or spreading of waves around obstacles or through gaps. Okay, so it bends more, or it kind of spreads more, kind of seen from on the right hand side here as it starts to curve as it moves through the gap. Okay. As you see, you've probably recognised this example, that's in your workbook, and the red line is one that has short wavelength, and black line is a longer wavelength, and you can see that reaches the house because it diffracts more around the hill. Okay, so again, that's something you will need to know for diffraction. Now, sound. There's lots of things about sound. We know that the speed of sound is 340 meters per second. We know that the speed of light, which is also the same for all the EM spectrum, is 3 times 10 to the power of 8. And
you just need to know a couple of the methods as well for measuring the speed of sound. So please do take the time. I'm not going to spend too much time going into them, but you need to know the methods of how to actually record the speed of sound. So one way was, remember, actually going out and using the symbols or hitting something and recording the time it takes when you see someone doing it and then actually you hearing it. That's one way of doing it, and that's there. Please pause the video if you want to look at that. Or the second one was when we had the timer and we actually used an electronic timer to measure the sound, the time it took to go from each sound sensor. Okay, so those are the two methods. Please take pause to have a look at them if you would like to look more into these. You've got them in your notes, so you should be fine. So yeah, if you're answering speed of sound experiments, also always mentions the things that you've measured, so your distance and your time. Always write in the equation. Always write in how you measured it. So you need to always write in stopwatch or sound sensors connected to a computer, and how you measured it using a ruler, trundle wheel, meter stick, and so on and so forth. Okay, so have a look at that. Make sure you always answer experiment questions thoughtfully and thoroughly. Okay. Right, hearing range, we don't really need to know much about this, but just wanted to put it in. Basically, you know that in a vacuum, when there's no particles, there'll be no sound, because sound needs to vibrate using particles. Alright, so just know that in a vacuum, there's no sound. Okay? Now, the EM spectrum, the last thing, you know the EM spectrum. This should be fairly easy for you. We go from low frequency, long wavelengths of radio waves, all the way up to short wavelengths and high frequencies. Now that is a table that you should know. You should always get full marks in these questions. It is not tricky. All of those waves travel at 3 × 10 to the power of 8 meters per second. And this is an important table that will be in every single one of your booklets. You need to know the uses and how it's detected for each of the EM spectrum. I'm not going to go through it now. We've taught you this. You should now have an idea of what each of these are. So please do memorize those for your test. That is an easy mark to get. And lastly, just know that the higher the frequency, the more energy that radiation has. So for example, gamma rays will often have, or will have, the most energy out of all the EM spectrums. Okay? Now, that's essentially it. That is a whistle-stop tour of this stuff. And National 5, just take your time with it. I've got some past paper questions for you now. Go and complete them. Have a little bit of fun with that. They shouldn't be too tricky. Hopefully give you some confidence going in to the prelim that you've done some of this stuff. But do give it your best shot. Alright, National 5, well done. Thank you for watching this video, and I hope you have a great day.